My dear students, welcome back to our channel. In this video, I will be explaining the BCA 5th semester subject Object-Oriented System Development as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 3, first important short question is: what is an artifact? In object-oriented system development, an artifact is a physical or tangible piece of information produced or used during software development. It represents the work products of a system, such as documents, code files, models, or diagrams. Simple meaning: think of an artifact as a building block of a software system. Just like bricks, cement, and beams are needed to construct a house, artifacts are needed to build, maintain, and understand a software system. Examples of artifacts: 1. Source code files, the program instructions. 2. UML diagrams, class diagrams, use case diagrams, sequence diagrams. 3. Documentation, requirements, design documents, user manuals. 4. Executable files, compiled programs ready to run. Example: in an online shopping system, artifacts include use case diagram showing customer interactions, source code of the checkout module, user manual explaining how to place an order. Why artifacts are important? They represent the system physically, not just abstract ideas. Help developers, testers, and clients understand the system. Essential for maintenance and future updates. Easy trick to remember: artifact is equal to anything that represents or is produced by the system. So, whenever you think of a document, code, or diagram, remember it is an artifact that helps in building and understanding the system. Next important short question is: 2. Define collaborations. In object-oriented system development, a collaboration is a relationship between objects that work together to achieve a specific goal or task. It shows how multiple objects interact to perform a function in the system. Simple meaning: think of a collaboration like a team of people working together to complete a project. Each team member, object, has a role, and by coordinating their actions, they achieve the desired result. Example: in an online shopping system, consider the place order process. Customer object selects products. Shopping cart object adds and stores selected items. Payment gateway object processes payment. Order object confirms and records the order. All these objects collaborate to successfully complete the order placement. Why collaborations are important? Show dynamic interaction between objects. Help in designing communication and dependencies in the system. Make complex workflows easier to understand. Easy trick to remember: collaboration is equal to teamwork of objects to achieve a goal. Whenever multiple objects communicate and coordinate, they are collaborating. This helps in modeling realistic system behavior in UML diagrams. Next, Unit 3. Long questions. First important long question is: 1. Discuss about architectural modeling. In object-oriented system development, architectural modeling is the process of designing and representing the high-level structure of a software system. It shows how different parts of the system are organized, interact, and depend on each other, giving a big-picture view of the system before diving into detailed design. Simple meaning: think of architectural modeling like creating a blueprint of a building. Before constructing a house, architects design the layout, showrooms, doors, electrical connections, and plumbing. Similarly, in software, architectural modeling shows components, their interactions and deployment before actual coding. Key elements of architectural modeling. 1. Components, independent building blocks of the system, like modules or classes. 2. Connectors, show interactions between components, like communication links. 3. Configurations, the arrangement of components and connectors. 4. Artifacts, physical or digital products like diagrams, code or documents. 5. Patterns and frameworks, reusable designs that provide proven solutions to common problems. Purpose of architectural modeling. 1. Understand the system, helps developers and stakeholders see the overall structure. 2. Plan development efficiently, guides the implementation of components and interactions. 3. Ensure scalability and maintainability, well-designed architecture can handle future changes. 4. Communicate with team, a visual representation makes discussions easier. Example. In an online shopping system, architectural modeling can show components, user interface, shopping cart, payment gateway, inventory system. Interactions, how the user interface communicates with the cart and payment gateway. Deployment, which components run on servers, which run on client machines. This model helps developers understand responsibilities, dependencies, and data flow before starting the coding phase. Easy trick to remember. Architectural modeling is equal to blueprint of the software system. Just like a blueprint guides the construction of a building, architectural modeling guides software development, ensures clarity, structure, and efficiency, and makes it easier to manage complex systems. It's a must-do step in object-oriented design to make software organized, scalable, and reliable. Next important long question is to explain about patterns and frameworks. In object-oriented system development, patterns and frameworks are powerful tools used in architectural modeling to make software development easier, faster, and more reliable. They provide proven solutions to common design problems and help in building robust systems. 1. Patterns. A pattern is a reusable solution to a common design problem in software development. It is not code, but a guideline or template that shows how to solve a specific problem effectively. Example. Singleton pattern ensures that a class has only one instance and provides a global access point. In an online shopping system, a payment gateway class can use a singleton pattern to make sure there is only one connection to the payment server, avoiding multiple conflicting instances. Benefits of patterns. 1. Provide tried and tested solutions. 2. Improve code reusability. 3. Make system design more organized and understandable. 2. Frameworks. A framework is a pre-built structure of code that provides a foundation to develop applications. It includes classes, libraries, and tools that can be reused. Developers can extend and customize frameworks instead of building everything from scratch. Example. Spring Framework in Java helps developers build web applications quickly. In an online shopping system, a framework can provide modules for user authentication, database access, and payment processing, saving time and effort. Benefits of frameworks. 1. Reduce development time. 2. Encourage standardized design. 3. Make maintenance and scalability easier. Difference between patterns and frameworks. Feature pattern framework. What it provides: solution template, reusable code structure. Usage guideline for design directly usable in applications. Example: Singleton, Observer, Spring, Django. Easy trick to remember. Pattern is equal to recipe tells you how to cook. Framework is equal to pre-built kitchen gives you tools and space to cook. By using patterns and frameworks, software becomes efficient, reliable, and easier to maintain, allowing developers to focus on business logic rather than reinventing the wheel. This makes them essential tools in architectural modeling of any object-oriented system. Next important long question is 3. Discuss about the artifact diagram in detail. In object-oriented system development, an artifact diagram is a UML diagram that shows how artifacts, physical or digital work products, are organized, deployed, and related in a software system. It is mainly used in architectural modeling to represent the physical view of the system. Simple meaning. Think of an artifact diagram as a map of all the important files and components that make up a software system. It shows what artifacts exist, where they are stored, and how they interact. Key elements of artifact diagram. 1. Artifacts, physical or digital entities like source code, executables, databases, or documents. Example, order.cl as, payment module.jar, user manual.pdf. 2. Nodes, physical locations or devices where artifacts reside, like servers, clients, or databases. Example, web server, database server, client machine. 3. Dependencies, shows how artifacts depend on each other. Example, order processor.cl as depends on payment module.jar. 4. Components, sometimes artifacts are grouped into components for better organization. Purpose of artifact diagram. 1. Visualize physical structure, helps understand where artifacts reside and how they are deployed. 2. Plan deployment, shows how components will be installed on hardware nodes. 3. Identify dependencies, helps in managing updates and maintenance. 4. Documentation, provides a clear picture of the system for developers and stakeholders. Example, in an online shopping system. Artifacts. Checkout service.jar handles checkout. Payment gateway.cl as handles payment. Database.sql stores orders. Nodes. Web server hosts checkout service.jar. Application server hosts payment gateway.cl as. Database server hosts database.sql. Dependencies. Checkout service.jar depends on payment gateway.cl as and database.sql. This diagram helps developers understand the physical layout of the system and ensure proper deployment. Easy trick to remember. Artifact diagram is equal to map of system files and where they live. It's like knowing which items go in which room in a house, making it organized, manageable, and easy to maintain. Artifact diagrams are essential for deployment planning, system documentation, and understanding the physical structure of object-oriented software systems. Next important long question is 4. Explain about deployment diagrams with example. In object-oriented system development, a deployment diagram is a UML diagram that shows how software components, artifacts, are deployed on hardware nodes in a system. It focuses on the physical architecture, helping developers understand how software and hardware interact. Simple meaning. Think of a deployment diagram like a floor plan for software. Just as a floor plan shows where rooms, furniture, and devices are placed, a deployment diagram shows where software components run and on which devices. Key elements of deployment diagram. 1. Nodes, physical devices or execution environments, such as servers, clients, or IoT devices. Example, web server, database server, user laptop. 2. Artifacts, software components or files deployed on nodes. Example, order processor.jar, payment gateway.cl as database.sql. 3. Communication paths show how nodes communicate with each other over networks. Example, web server left and right arrow database server via TCP/IP. 4. Dependencies indicate which artifacts depend on others to function. Purpose of deployment diagram. 1. Visualize physical deployment of software. 2. Help in system planning and installation. 3. Show interactions between hardware and software. 4. Aid in troubleshooting and maintenance. Example, in an online shopping system. Nodes. Client machine runs the web browser. Web server hosts checkoutservice.jar. Application server hosts paymentgateway.cl as. Database server hosts database.sql. Communication paths. Client machine web server application server database server. Artifacts. Checkoutservice.jar deployed on web server. Paymentgateway.cl as deployed on application server. Database.sql deployed on database server. This diagram clearly shows how software components are distributed across hardware and how information flows between nodes, making it easier to manage the system. Easy trick to remember. Deployment diagram is equal to map of software on hardware. Just like you know which device goes in which room, deployment diagrams help developers know where each software component runs, making complex systems organized, efficient, and maintainable. Deployment diagrams are essential for planning, deploying, and understanding the physical architecture of any object-oriented system. Next important long question is 5. Explain about systems and models with an example. In object-oriented system development, systems and models are fundamental concepts used to understand, design, and manage software effectively. They help developers visualize complex systems before building them. 1. What is a system? A system is a collection of components working together to achieve a common goal. It can be software, hardware, or a combination of both. Simple meaning. Think of a system like a car. The engine, wheels, brakes, and steering are all components. Individually, they do different things, but together, they allow the car to run. Example. In an online shopping system. Components, user interface, shopping cart, payment gateway, inventory system. Goal, allow customers to browse products, place orders, and complete payments. Here, all components work together to provide a seamless shopping experience, forming a complete system. 2. What is a model? A model is a simplified representation of a system. It focuses on important aspects while ignoring unnecessary details. Models help in visualizing, analyzing, and communicating the system design. Simple meaning. Think of a model like a miniature airplane. It shows the shape, design, and function of a real airplane without being full-sized. Types of models in software. 1. Structural models show system structure, example, class diagrams. 2. Behavioral models show system behavior, example, use case, sequence diagrams. 3. Architectural models show system deployment and components, example, artifact deployment diagrams. Example. In the online shopping system, a use case diagram is a model that shows how users interact with the system, while a deployment diagram shows where each component runs physically. Why systems and models are important. 1. Models simplify complex systems, making them easier to understand. 2. Help in planning and designing software efficiently. 3. Allow communication among stakeholders without confusion. 4. Support maintenance and future upgrades by providing a reference. Easy trick to remember. System is equal to real thing, model is equal to map of the real thing. The system is the complete working software. The model is a visual or abstract representation to understand, design, and communicate how the system works. Using systems and models, developers can plan, design, and implement software in a structured and error-free way, ensuring reliability and efficiency.